Probably the most important day of the year is today. Simply because we're going to talk about stuff that just doesn't go away. Alrighty, so what I've done is I've cut the test into thirds as far as the way I'm going to teach it, and I got through most of what I had today, so hopefully we can just keep rolling here. So here we go. Alright, so it is 11:12 today. Alrighty, so this is also some of my favorite stuff because this is the math of chemistry, okay? And that's really when you talk about stoichiometry, which is what that word is, stoichiometry. That's stoichiometric, but stoichiometry is basically the math behind chemical reactions, okay? And we're gonna do a ton of that today. Now, for starters, did anyone do any of this and had any questions on it? Okay, I put this. If you weren't here, this is online. There's a stack right here, but I uploaded this for those of you that weren't here. But are there any questions on any of this? Did anybody do any of these that they couldn't do, or any of that? Yeah.
45.
45. Okay, 45 said this. Ca3PO4 taken twice plus SiO2. Did you think that was a 12? Did you think that was a 12?
I don't think so.
Okay, P4O10 plus Ca SiO3. SiO3, like that, right? Well, right off the bat, I got a P4 over here, right? Over here I've got 2, which means I probably need at least a 2 right there, right? Correct?
Yeah.
Okay, but then that gives me 6 calciums. So I'm going to come over here and I'm going to put 6 calciums in there, right? Right? But then that gives me 6 silicons, right? So I'm going to put a 6 for that 6 silicons, correct? Now I've got to go back and basically just look at my what now. The only thing that I haven't already balanced is my what? My oxygens, right? What was here? That's where I started, wasn't it? So I started as though that was a what? A 1, right? So how many oxygens do I have here? I got those 8, but times that 2, doesn't that give me 16 O's right there? Right? Plus that's what? 12 O's, right? So that gives me, what's that, 28 O's over here. I got 10 O's there. How many O's are here? 18 O's, right? That gives me 28 O's. Does that work? Yeah. Does that make sense?
Yeah.
All right. Okay. All right. Now, we are going to cover, like I said, we've got at least a full hour to discuss. So let's get after this. Now, what's going to happen is if you do not have a calculator out and your periodic table out, you're in trouble. And your calculator cannot be your phone. If you need to borrow a calculator, you put your phone in the box on my desk and you grab a calculator. No phones. Okay? Like now. From now on, do that as soon as you walk in. Have to have a calculator and a periodic table out every day. Alrighty, so we're going to start with this equation. 2C2H2 plus 5 O2s yields 4 CO2s plus 2 H2Os. Now, this is what's going to happen. They're going to say something like this. Given 47.6 grams of C2H2 and excess O2, how many grams of CO2 will be produced? Okay, now, what's happening is this. Let's say I go out in the forest and I build a fire, right? How long is that fire going to burn? Blizzard.
Depends how much wood there is.
How much wood there is, right? So when is that fire going to go out?
When the wood is,
When the wood is gone. Why?
because there's no more oxygen.
Now, where does the oxygen come from? The oxygen comes from the atmosphere, right? Is that oxygen going to run out? No. So the wood becomes what's known as your limiting reactant, okay? Now, down the road, in a few minutes, we're going to actually do one where we calculate that. But for right now, if they only give you one value, that's the value you do this with. Okay, now, I'm starting with 47.6 grams of C2H2. When I'm done, where do I need to be?
CO2.
I need to be in grams of CO2. Now, does anybody know what this equation really tells me? Anybody take regular chemistry and knows what this means? Is that your phone blowing up on my desk? Is that where that's coming from? Go turn that off, will you, please? Nobody knows what this says? Are both your phones up there? Oh, check it and see, will you? So what this says is these coefficients are in 2 units. They are in moles or they are in molecules. They are never, ever, ever in grams. Ever. So this says that if I have 2 moles of this, I need 5 moles of that. And I'm going to produce 4 moles of that and 2 moles of that. Or it says I have 2 molecules of this and I need 5 molecules of that to produce 4 molecules of that and 2 molecules of that. So, if it gives me in grams, I've got to go to what? Very first. Moles or molecules, right? For what we're going to do, it's going to be moles like 90% of the time. More like 99.9% of the time. How do I go from grams to moles? What?
Don't you put grams on the bottom or something?
I put grams in the denominator. But what's going to go there? What's this going to be? It's going to be its what? Did this shit last time. Towards the end, this is going to be its. I'm in grams. I need to get to moles. I'm going to use its. What? It's molar mass. How do I calculate its molar mass? How did we calculate molar mass last time? Party, right? Have a party. Do it. Calculate its molar mass. I don't need to practice this. Somebody calculate me the molar mass of C2H2. Everybody should practice this. Everybody. That's why I had you get out your periodic table and a calculator. This is like 30% of the test is going to involve what we do today.
I think it's 26.038.
26.038. My last class got 25.04. I don't know who's right. So we got 2 carbons, right? That's 2 times 12.011, right? Plus 2 H's, 2 times 1.008, is it? I got 26.038. Anybody else get that? Okay. So somebody screwed that up. 26.038 grams of C2H2. Now, that's going to put me into moles of C2H2. Now, for moles of C2H2, I've got to go to moles of what it asks me about. What does it want me to find? It wants me to find grams of CO2. But before I can go to grams of CO2, I've got to go to moles of CO2. So I'm going to go with what's called right here. This is called the mole to mole ratio. Sometimes I refer to it as the molar ratio. Okay? So, what is the mole to mole ratio of CO2 and O2? Where do I get that? Which is why we started with balancing the equation, right? That's why that was the first thing we did. None of this math matters if the equation has not been balanced. So what's it going to be? What am I going to write here? So I'm going to write what?
2 over 4.
2 over 4?
Maybe.
So I want to go to CO2, right? So if I put CO2 in my denominator, what happens to things in my denominator? Don't they usually get reduced out? So my CO2 needs to go in my... So I'm going to go 4 moles of CO2 for every 2 moles of C2H2. And notice my moles of C2H2 are going to reduce out, right? What's going to happen to my grams of C2H2? They're going to reduce out. Now, if I stop there, I would be in moles of CO2. But the question didn't ask me to find the moles of CO2. The question asked me to find the grams of CO2. So now I've got to go back to what? Back to grams. So now what am I going to use? So the moles are going to go in the denominator. So I'm going to go 1 mole of CO2 in the denominator because I need it to go away. What's going to go in my numerator? It's molar mass, right? But now I'm doing the molar mass of CO2, which is 44.009. Yeah? Grams of CO2. So my moles of CO2 reduce out. The only units I have left are grams of CO2, which is what it wanted me to find, right? Now, everybody do the math. And I need someone to tell me the answer. Hey, when I'm done teaching today, remind me to replace my last discussion online because they screwed that number up and I don't want a whole bunch of kids at home going, that's not what I got. You know what I'm saying? Anybody get this value?
160. Do you want it in sig figures?
Oh, what do you think? Probably. Give me the real number, the number your calculator gave you. 100 and what?
160.905.
905 grams of CO2, right? Now, what's the answer going to be?
That wasn't the whole number.
Oh, that wasn't the whole number?
Yeah, 905.4766.
Whatever. Okay. Yeah. What's the answer?
161.
161 grams of CO2 is Torgerson, right? Why do you say 161?
Because the first number is
Because that number has 3 in it, right?
Yeah.
That's my limiting, or that's my determining factor. It's got 3 sig figs. My answer's got 3 sig figs. And typically when you do this, you always want to do the math so that whatever they give you is always your determining factor. Never have any of these conversions be less than that. Okay, I would always just give the whole numbers here. That way you're going to have the best answer possible. Okay? Now, suppose you actually produced 145 grams of CO2 in the lab. What is your percent yield? Now, this is a very common calculation you do if you're in a lab setting because you want to see how good you're doing it. Okay? This value we got right here, this value is what the math said we should get, right? But when I go in the lab, am I going to get that value? Not unless I do the lab perfectly. And for me, there's a shit. No, just kidding. Just kidding. Okay? So, percent yield is easy. Percent yield is actual divided by theoretical. Okay? Actual comes from the lab. Theoretical comes from the math. Okay? So, what are we going to write here? 145 over 161, and that's going to give me what? Now it's percent, so what do I do when I'm done? I just automatically times that by 100, don't I? Turn that into a percent. Anybody get that? 90.062, is he right? 90.062. Okay, percent. Now, is that the answer? What's the answer going to be? 90.1%. Why is it 90.1%? Because I got to have 3 sig figs, right? That 6 makes that a 1, 90.1%. Yes.
So, back up there. How
Yeah.
did you get the 44.009?
We did what? How did we calculate this? We did the party method, right? We just used what? We used grams, those numbers on the periodic table, instead of electrons, because it's the same thing we did, right? When we did the Lewis dots, we did a party, except that time we invited the electrons, right? In molar mass, I'm doing a party, I'm just inviting the mass instead. That's that little number at the bottom. It's got 3 decimals on it. Like, look at carbon. Carbon should be 12.011, right? Yes.
What did you times by on the top?
Where?
Like, what was the math on the top, like, when they times them and then divided?
Right here?
So it was those two right there?
It would be all these times together divided by all those.
So that was times by the 1, times by, like, the 4? I think.
So what I do is I open a parenthesis, and I go that, times that, close my parenthesis, hit the divide key, open another one, that, times that, close it, enter, and it's going to spit that out. Then you can do it all in one calculation. Yes?
Okay, I might be wrong, but I've done it like 3 times and I keep getting a different number than 44.009.
For this?
Yeah. Really? Am I doing it right?
I didn't do the math. I don't know. So C is 12.011, right? 12.011 plus 15.999 times 2. I get 44.009.
Oh, that's what you, oh, okay, yep.
Yeah?
Oh, 999, okay.
Gotcha? Okay. Alrighty. Now, this is something that is not going to go away. So you need to make sure you are doing this and practicing it because this is like a third of the test. Okay, now, let's say I did this one. So I got SiO2 plus HF yields SiF4 plus H2O. And it says, given 111.4 grams of oh well, that's all right, of SiO2 and excess HF. How many grams of H2O should be produced? Okay, almost the same exact type of question. Okay, and notice they only give me one value here. That's the only starting value they give me, right? Which means I know that that's a value I'm going to use to do all my math, right? So I'm going to start out with 111.4 grams of SiO2. Okay, where do I know I'm going to go? If they give me grams, 99.9% of the time, my first calculation is going to be to what? To moles, right? Now, what's going to go here? What's going to go in my numerator no matter what? 1 mole of SiO2 for every what? Nobody can do SiO2?
60.084.
What?
60.084 grams.
60.084 grams of SiO2. Anybody get that besides Cooper? Okay. So that's that. What comes next? Your mole-to-mole ratio, right? So what's that going to be? You've all failed the test, by the way. Ah! There's a reason I taught that very first. Rule number 1 is if they're, no matter what, you need to balance an equation. That should be the first thing you do is mentally. And even if they have numbers there already, I would go through and mentally make sure those numbers are right. Do we all understand that? Balance that. That should have been the first thing you did. You have it? What do you got?
1 SiO2, 4 HF, 1 SiF4, 2 H2O.
Anybody else get that? Okay, so now what's my ratio going to be? What am I going to? I'm going to grams of H2O, but before I go to grams of H2O, I got to go to moles of H2O. So I'm going to go 2 moles of H2O for every 1 mole of SiO2, right? Correct? Now, if I stop there, my answer would be in moles of H2O, right? Which they might ask you to do. But this one didn't ask you for moles, it asked you for grams. So now I've got to do what? Now I've got to go back to grams, but now I'm going to use the molar mass of H2O. And what's it going to be? 18.015 grams of H2O for every 1 mole of H2O. Now watch what happens. My moles of H2O reduce out. My moles of SiO2 reduce out. My grams of SiO2 reduce out, leaving me in grams of H2O, which is what it asked me to find. Right? So what do I get here? You don't have it?
I do. It's 66.802.
66.802.
176.95.
That would be grams of H2O, right? Now, obviously, that is not the answer, right? Why, Fisher?
Because it has
Too many sig figs, right? Which number do I want to be the one that dictates my answer? Whatever's given, right? My given number has 4 in it. All of my conversion factors, do they have at least 4 in them? What about this middle one? They don't count, right? So that's got 5, that's got 5, that's got 4. My answer can have 4 sig figs. What is it? What do I get then? 66.80 grams of H2O. Just like that. Did anybody else get that besides Fisher? Yeah, you realize that I just expect you to have the answer? Okay, it's like that letter. Were you here when I read that letter to the class from my student that cried herself to sleep all the time? Did I read you guys that letter? Yeah. Okay, so I went to the wedding and talked with her and her parents, and I explained to her that I've never forced a student to do anything. I mean, if I ever sit down and physically forced you, I haven't. I go, so how do you write that? And she goes, well, you just expect us to. I'm like, well, don't all your teachers expect you to? And she told me no, and that really kind of bothered me. Do not all your teachers just expect you to do your work? No? The hell? Well, I do. And I guess I'm all that matters, so. What did that mean?
Huh?
I saw a little tuh.
No, I just laughed.
Why?
Because it was funny.
Oh, okay. Well, whatever. Alrighty, now. Next thing we're going to discuss is what is known as limiting reactant. Okay? The limiting reactant is the reactant that is totally consumed. Okay? Now, there's a lot of different ways to teach this. And in my, I think it's 19 years of teaching chemistry, I've taught this 4 different ways. Okay? I'm going to teach you the way that I think has worked the best over that time. And that's just the way it is. Now, let's say I got a bunch of friends over. They're all hungry, right? So I'm like, let's make some sandwiches. So I go to the fridge, pull out some bologna, and I got 7 slices of bologna, right? I open the cupboard and grab the bread, and I got 12 slices of bread. How many sandwiches can I make? 6 or 7? Why 6? I only have that many slices of bread, right? So that makes my bread my limiting reactant. That makes my bologna be in, what was the word I used it earlier today? My bologna is in, it was also a band from the 80s. In excess. Didn't I use the word excess earlier today? I see Bella shaking her head.
That's a long time ago.
Excess of O2 right there. Yeah. In Excess was an 80s band. They sang a song called Wild Wild West. It was really popular for a while. Not that Wild Wild West. That was Will Smith's. Now, what's going to happen is this. You're going to basically just do this problem twice. Whichever one gives you the least amount is going to be your limiting reactant, right? So we looked at our sandwich, and our bread and our meat, right? My bread made me 6 sandwiches. My meat would have made me 7, right? But I couldn't make 7 because I didn't have enough bread. So that's what we're going to do. Because we know how to do the math now, we're just going to do the problem twice. Because it's pretty much the same thing, right? And then whichever one gives me the smallest output is going to be what is my limiting reactant. So watch. So let's say I give you this. So I got C7H16 plus O2 yields CO2 plus H2O. Okay? Now, this is what it's going to say. It's going to say given 97.6 grams of C7H16 and 100.1 grams of O2. Okay. How many moles of H2O will be produced, and which is the LR for limiting reactant? Okay. Now, this is what you're going to do. We're going to basically just do exactly what we did. We're going to find out how much water is produced. Whichever one produces the least amount is my limiting reactant. Now, can anybody tell me what is different about this problem than either of the two we've done? What? It does. It gives you two. It gives me this, and it gives me that, something else. Blizzard. It wants the answer in moles. So Blizzard, I think I got some Sour Patch Kids. If you can tell me how that's going to change what we do.
Well, you don't have to convert it to grams at the very end.
Nice job. At the end, what it really does is if I go back up here, right? If I would have stopped right here, my answer would have been in moles. But we didn't. We had to go to grams. Well, this one says moles, so I'm just going to stop a step earlier. It's going to save me that last step. Okay? So, I'm going to do the exact same thing I did up here, except I'm going to do it twice. I'm going to do it once with this, and I'm going to do it once with that, except I'm going to stop right there. Now, you're all failing again.
Not necessarily.
Oh, you're like actually doing it?
Yeah.
Oh, okay. Was anybody else? Had anybody else started that? Okay, this one is hard because you end up with an odd number. Did we go over this the other day? Yeah, we did this one, I think. I think you should have this done. I think it's 1, 11, 7, and 8, right? Okay. Now, so I'm going to start. Does it matter which one of these I start with? No, because I'm going to do them both. So I'm going to start with 97.6 grams of C7H16. I'm going to times that by what? What am I doing first? Going to moles, right? So I'm going to have 1 mole of C7H16 for every what? People, you need to have your calculator out and you need to be doing these calculations. And to make sure you know how to do them. You don't want to have the first time you use your calculator be the test. Say that again. C7, H16? Sorry, that's a 7. C7, I'm like, wow.
I got 100.205.
100.205. Anybody get 100.205? That is grams of C7H16, okay? Times that by what? What's coming next? What is this called? Mole to mole ratio, and it is? What's going in my numerator? 8. 8 moles of H2O for every what? 1 mole of C7H16, right? Now, I'm stopping there because this asked me for moles, right? My moles of C7H16 reduce out. My grams of C7H16 reduce out, and I end up with what? And I don't care if you go right to sig figs, that's fine. How many sig figs does my answer need to have in it? 3. 3 sig figs. 7 point, say it again. 7.79 moles of H2O. Anybody else get 7.79 moles of H2O? Alrighty, so that's one answer. I'm just going to keep that for a minute. Yes?
How did you get that 8 moles of H2O?
Came from my mole to mole ratio here. It's 8 moles of H2O for every 1 mole. That's why rule number 1 is to do what? Balance the equation. You don't balance the equation, you're never going to get the question right, ever. Okay? Now, I'm going to do the same thing with my oxygen, right? So I'm going to go 100.1 grams of O2. Times that by what's going to go next now? So I'm going to go 1 mole of O2 for every 31.998 grams of O2. Then what's going to go next? Which is now 1 to 11? 8 over 11? So it's 8 moles of H2O for every 11 moles of O2, right? Moles of O2 reduce out, grams of O2 reduce out, and I'm left with what?
Two point two seven five.
2.275 moles of H2O. Anybody back Torgerson up? Yeah? Okay, so obviously this one is the smallest, right? So what does that mean? It means that whatever produced that was my, means that right there is my limiting reactant. What does that tell me about my C7H16? It's in excess. Does that make sense? All righty. Now, from there. Okay, so they're going to ask these questions lots of different ways. So let me share this one with you. Let's say I went with KClO3, breaks down to yield KClO4 plus KCl. Okay? And I said this. Okay. Now, you know what? Let's change this. Check that. Let's do this. Let's go molecules of KClO4 will be produced. So we've done it in grams, right? We've looked at it in moles. Now let's say I want to look at it in molecules. Now what is nice about this question? They done anything to help us out here? What? Yeah, I don't got to go from grams because it already started in moles, right? So I know that I'm going to start with 4 moles of KClO3, right? That's where I'm starting. Yes. Ah, now we're picking up. Bounce. Anybody bounce this for me already? 431. Is she right? Anybody else get 431? Yeah? Okay, so we're 431. So, I'm going to start with 4 moles of KClO3. Now, it asks me to find molecules of KClO4. Now, we haven't talked about this yet. But what do I know before I can find molecules I've got to find? Before I can go to molecules, I've always got to go to moles. You're going to go through the mole-to-mole ratio like 99% of the time. So I'm going to start by doing what? What's going to go first? So I'm talking about KClO4, right? What's my mole-to-mole ratio of KClO3 to KClO4? It's 3 moles of KClO4 for every what? 4 moles of KClO3, right? Now, if I stop there, I would be in moles of KClO4, right? Now, it wants me to get to molecules. Does anybody know that number? Yeah, I'm looking at you.
It's 6.02 times 10 to the
23rd molecules in every molecules of KClO4 for every 1 mole of KClO4. Now listen, people. Do you know what that is, Fisher?
Isn't it called like
Yeah, okay. 6.02 times 10 to the 23rd is equal to 1 mole. Okay, and this is known as Avogadro's number. Okay, Avogadro's number. Now understand this. This value right here is in atoms, or it can be in atoms, it can be in molecules, or it can be in FUs. Okay? That stands for formula units. Ionic compounds are considered what's called formula units. So if whatever I'm talking about exists as an atom, like gold, I would use the term atoms. If what I was talking about is sugar, I would use molecules because sugar exists as a molecule. If I was talking about salt, I would use formula units because salt exists as a formula unit. Okay, I appreciate that. In my class yesterday, every time I wrote down FUs, they would giggle, and I'm like, oh my hell, we're in high school, people. Yeah. Now, so, do the math. Tell me what we're going to get. Use the EE button. Everybody look. I probably should have shown this in my last class. Everybody watch. This is how you do 6.02, 10 to the 23rd. It goes 6.02. Hit the second EE button like that. That means times 10. And then just go 23. That is 6.02 times 10 to the 23rd. Do not use the 10 key or any of that other crap. Do it just like that, and it works every time. Do we all understand that? Okay? So, do that calculation and tell me how many molecules you're going to end up with.
On the very last thing, what's on the denominator?
1 mole of... Oh, that should have been... Yeah, I don't know. Oh, yeah, because that many molecules is 1 mole. This is my conversion factor, right?
1 mole for...
1 mole of KC, because that allows my moles of KClO4 to reduce out. Then it allows my moles of KClO3 to reduce out, right? Yes.
Wait, so what did you say you pressed your calculator? The second one.
Second EE. It's a second comma. So go 6.02 and then go second comma. And it puts that little E right there. That means times 10 and then just go 23. That's what gives it to you. Okay? What do you got?
2 times 10 to the 24th. No, not
It's not. It's close, but it's not.
1.806 times 10 to the 24th.
1.806? 1.806 times 10 to the 24th molecules of KClO4, right? Now, here's my question. What is my answer going to be? Does anybody know? There's kind of a problem with this problem, but it gives us a good thing to talk about. Okay, so you why do you think 1?
Because you don't have to, so you can.
Well, I go back to this, but what's wrong with using just 1? What kind of number was this? Does anybody remember? It was a counting number. Do you remember what I taught you about counting numbers, Fisher? They don't count. Okay? So that one wouldn't be, because in theory what they say is it's got an infinite number of decimal places. Well, I can't have an infinite number of decimal places. So what's the only other number in there I could use? Yeah, I would say probably this one, and it has 3 in it, so my answer probably better have 3. Typically you wouldn't use that, but because I don't have a very good number there, I have to. Now, how could they have changed this and made it a better number to use? Yeah, they probably, if they'd have went 4.0, now I'm going to use my 2 sig figs. Do you see the difference there? So the answer here should probably be 1.81 times 10 to the 24th molecules of KClO4, just like that. Okay? Does that make sense? Okay, this is what we're going to do. We're going to go, we got to hurry, but I want to do one more of these. So let's do this. So let's say I give you this. I'm going to go Fe2O3 plus H2 yields Fe plus H2O. And I want this. I want to know how many grams of Fe are produced from 2.76 moles of Fe2O3. Okay? Balance it, do the math. I will be right back. Somebody got it? Nobody? One? Two? That's it? Nobody else has this? What's the matter? What's the matter?
I don't know.
Well, let's do it. So, what's the first thing I have to do? Got to balance it, right? So, what is it balanced? Anybody balance it? What does it balance as? 1, 3, 2, 3. 1, 3, 2, 3. She right? Okay, so it says how many grams of Fe are produced from 2.76 moles of that, right? So I'm going to start with 2.76 moles of Fe2O3. What did I do there? Yeah, I started in moles. So what did I save you? I saved you that first step, didn't I? Of going from grams to moles. So what's going to go next? Mole to mole ratio. What's my mole to mole ratio going to be? 2 moles of Fe for every 1 mole of Fe2O3, right? Okay. Now that would put me in moles of Fe, but the question asked me for grams of Fe. So what's going to go next? 55.845 grams of Fe for every 1 mole of Fe, right? My moles of Fe reduce out. My moles of Fe2O3 reduce out. My answer is going to be in grams of Fe. What'd you get, Torgerson? 308 grams of Fe. Because I had 3 sig figs there. I need 3 sig figs there. Did you get that, Fisher? So what was wrong? What didn't we see?
I just did the wrong mole in mass.
You did the wrong mole to mole ratio?
No, the wrong mole in mass. I did Fe2O3, so
So you did that. If you did that, you probably would have came back to the same answer, right?
I don't know what I did good wrong, because I got like 800 something. I don't know.
Heslip, what's your problem?
Huh? I figured it out. I was overthinking it.
Well, stop it.
Thanks.
I do what I can. Okay. What about the rest of you? What aren't we seeing? See, if you don't tell me, I cannot help you. I don't have ESPN. That's a joke in case you didn't get that, but yeah. Yeah, when you try to tell the teller she's wrong, she doesn't want to listen to you. You almost just want to take your money and go. I'm at Kent's the other day. Did I tell you guys this story?
No.
So I'm at Kent's the other day, and I bought a case of rock stars. And the lady rings me up wrong, and I'm like, yeah, that's not right. And she's like, yeah, it is. And I'm like, no, it's not. And then I use my line. I'm like, I know a math guy. And the bagger says, he's talking about him. He's talking about him. See how I say it, yeah. That's pretty accurate, wasn't it? It was funny. She was just waiting. What?
That's how it went. Yeah.
That's how it went. Yeah, it was funny. It was her. Yeah. Yeah. The teller didn't quite, she was going to resist for a minute. What? And I'm like,
First day, she was
literally, I'm like, I know a math guy. She obviously didn't know who I was, but she didn't. She said, he's talking about him. It was funny. Yeah, it was funny.
After you said that she took your Chem 11 Chem class, and she said, I'm selling houses now. How am I using chemistry in that? And I was like, oh no.
She's selling houses?
Yeah, the lady behind you. There was like you, and then the guy, and then the next lady.
And she was in my class?
Yeah, that's what she said. She said, I took Chem 11 Chem from him. And I was like, I'm taking it right now.
Who was it?
I don't know.
Wow, that was funny because the kid I taught in 03, he wanted to talk all night. It was so funny. And then the next one was also, I probably didn't recognize her. She had her face mask on. That's funny.
Yeah.
And she's selling houses now?
Yeah, she said that she's like a realtor.
Well, when it comes to like radon gas testing and stuff, it could come in handy. Yeah. So, yeah, I can always find something. Oh shit, we gotta hurry. All right, redox. Redox reactions. Anybody do this Learn Smart that mentioned redox reactions? Yeah? Okay, so redox comes from the term oxidation / reduction. Okay? What happens is this, in lots of chemical equations, this doesn't apply to everything because not every equation is a redox reaction. Okay? But some are. Like if I have a single replacement reaction, it is always redox. If I have a double replacement reaction, it is always non-redox. Okay, and it's changed how it's been taught over the years. Okay, I'm going to teach you the way that works the best now. Back in the day, it used to mean to either combine with hydrogen or to combine with oxygen. Well, there are some equations that don't even involve hydrogen or oxygen, so it can't be used, right? So then they invented, the way to teach it with redox numbers. So this is what I've got. I've got 1C plus 1 H2O yields 1 CO plus 1 H2. Now, what you're going to do is you are going to assign oxidation numbers. Assign oxidation numbers, right? And then look for what changes. Now, what that means is this. Whenever something is elemental, like this carbon is, it always has an oxidation number of 0. Okay? Now, if you remember the last test, didn't the last test have a question about H2 on it? When asked about those diatomics, wasn't H2 on there? Oh, it was N2. Okay? Whatever. One of those 7 diatomics, this is elemental as well, so it has an oxidation number of 0. The rest you have to figure out based upon stuff you already know. Okay, so if I were to say, what does O like to be? Does anybody remember what that would be, charge-wise? What does O want to be? O wants to be a 2 negative, right? What does H want to be? A 1 positive. Does that work with this compound? Yeah, why? There's 2 hydrogens. Each one's a 1. That gives me a 2 positive. Cancels out that 2 negative, right? How about over here? Again, O is a what? 2 negative. Now, does anybody remember what I said about oxygen and being a 2 negative? 99%. There was one time. Okay, it doesn't matter right now, but just know that it's a 2 negative. Now, based on that, what does that make my carbon? 2 positive. Now, someone should be saying, hey, wait a minute. What does carbon usually like to be? A 4, either positive or negative. But remember, that's a general rule. It's not a hard and fast line. In this case, it's a 2 positive. Now, they're the oxidation states. These are called the oxidation numbers. So that's what we did. Look for what changes. Did I have some elements change oxidation number? Yes. Now, from there, you have to do oil rig. Anybody know oil rig? It's called a mnemonic device. Anybody know what a mnemonic device is? What? That right there is a mnemonic device. SOHCAHTOA, not Sacagawea, is a mnemonic device. Still the best story ever. Okay? Now, what it stands for is oxidation is loss of electrons. Reduction is gain of electrons. Okay? So I suddenly go and I look at these numbers and I figure out, did they gain or did they lose? So carbon went from a 0 to a 2 positive. So it lost electrons, right? So that means it was oxidized. Okay? My hydrogen went from a 1 positive to a 0. which means it gained, so that means it was reduced. And oxidized and oxidation are the same, reduced and reduction is the same. What about my O? It didn't change. So it was neither oxidized or reduced. All I've got to have is one thing being oxidized, one thing being reduced. Now, another thing they'll ask you for is if it is oxidized, it automatically makes it what is known as a reducing agent. If it is reduced, what do you think happens? It's the oxidizing agent. Okay, and that's how that works. They always go together like that. Okay? Now, let's do one of these. Okay, let's say I've got this. So I'm going to go Al plus 6 HCl yields 2 AlCl3 plus 3 H2. Sorry, that's a 2. I missed a 2 right there. Okay, so this is it. So it simply is going to say, is this, for instance, they'll say redox or not, right? And if it is, then you've got to list which ones it is, which one's which, right? So what is Al's oxidation number going to be right here? A 0, right? What is it over here? Anybody remember? Why do you say 3 positive? Fish? It's typically what it likes to be, but there's another way to figure that out. Because Cl is going to be a 1 negative, right? And I got 3 of them, which gives it a 3 negative, which means my aluminum had to be a 3 positive. Right? What about over here? Cl again is a 1 negative. My H is a 1 positive. Over here, though, my H2 is a 0 because that's how elemental hydrogen exists. Is H2, it's diatomic, right? Now, did something change numbers? Yes. So the answer to redox is yes. Then it's going to say one of 4 things. Find out what's reduced, what's oxidized, what's a reducing agent, what's the oxidizing agent, right? So I always just figure out what's oxidized and reduced first, because the other for that is just the opposite of it, right? So O, or Al, goes from 0 to a 3 positive. What did it do? It lost electrons, so it was oxidized. By default, then, that means one of these two have to be reduced. Which one is it? The hydrogen is reduced. How do I know it was the hydrogen? You're right, but even if I didn't know that, would I be able to figure that out? What did chlorine not do? It didn't change, so it can't be either. Does that make sense? But he's right. H was reduced because it went from a 1 positive to a 0, so it gained an electron. Gained a negative. 1 negative plus a positive, right? Now, because my Al was oxidized, that makes it my reducing agent. Because H was reduced, it makes it my oxidizing agent. Okay? That's what you got going there. And another dead giveaway is, let me know what kind of reaction that was. Single replacement. And remember what I said about single replacement reactions? They're always redox. Always. If it's double, it's never redox. If it's single, it's always redox. The others, you've got to do this to figure out. That makes sense?
How do you know it's single replacement?
So what you typically have is, see how I've got one thing here? See how that aluminum and that hydrogen basically trade places? Here my aluminum's alone, there my hydrogen's alone. This replaced that. One thing replaced another. If it was double, I would have 2 things that swap places. Okay? Alrighty, that's that. Questions? Yo.
Where'd you get the 0 on the AL?
Because it's by itself, which means it's elemental, which means if it's ever elemental, it's always a 0.
So if it's always by itself, it's 0.
Bingo. Yeah. The only time that's not the case is if it's one of those 7 diatomics, which is why they keep coming back. Remember the N2O2F2 we talked about? they'll be zeros as well. Other than that, it has to be a loan to be that. Okay?
And then also on the ALCL3.
Yeah.
The CL, since it has the 3, that means it has to have 3 negative CLs, right?
You're right. So what I got is each one's a -1 times by 3 gives me a net 3 negative,
Yeah.
which means that one aluminum has to be a net 3 positive.
Yeah.
Does that make sense?
So then how can you just write 1 negative?
Well, because I'm talking about each CL. Yeah, you don't want to do it as a group. You're talking about each CL.
Okay.
Does that make sense? And that'll be important. You got to do them per atom because that's how you'll tell if they change. Does that make sense?
But you know that, like,
Exactly. I just know that each one's 1 times 3 gives me a 3 negative, which makes that a 3 positive.
then you know.
Exactly.
You just want to find it.
Yep. Good question. Anybody else? Holy cow, that's the longest I've ever taught. Have I ever given a discussion that long? Well, this stuff is like muy importante. So, what? That's first. This is second. Alrighty. So, I would say use the rest of your time wisely, but I don't think you have very much, do you? How much time do we got? 5 minutes. Sorry, I gotta get this stuff in because we gotta have that test before the break. We will do the lab before we go on break. Well, yeah. So remember how we were gonna do it after? That last day's an A day. So it's gonna throw us off, you know what I'm saying? So we'll test on a Friday, but then we'll lab on that next Tuesday before we go to break. Which would be fine because it doesn't matter. I mean, it's not like, if we were to wait the test till after, I assure you, that would suck. Anybody that took the test later, other than you, did shitty.
Oh, great.
So,
Good job. Thanks.
well, I'm just saying, that's a fact. But you took it, did you take it after? But yeah, so you were like it. You're the only one.
Like, I took it on Monday.
Yeah, you're the only one that stayed. I think I like